Welcome back for part 2 on solving exponential and logarithmic equations. In this video, we are going to look at a couple more examples in which we solve exponential equations in which our bases are not the same. And what we're going to do is we're going to use that property of equality for logarithms in order to help us solve these equations. So our first example, 5 to the 2x equals 15. We know that 2x needs to get out of the exponent. And the only way we can do that is by taking a logarithm of both sides. So in this step, what I'm going to say is you have two options. You can either take the natural logarithm or you can take the common log. It does not matter which step you choose as long as you do the same to both sides. You could take log base 12 of both sides if you want, and now that's going to make your life a lot harder. As long as you take the same base logarithm of both sides, you're going to be able to get that 2x out of the exponent. I'm going to work with the natural log just because I find that easiest, but again, choices usually are the common log or the natural log. It does not matter. So, because we have an exponential with a variable in the exponent, the first thing we want to do is we want to take the natural log of both sides. So we're going to go ahead and take that natural log. So we have the natural log of 5 to the 2x is equal to the natural log of 15. And by taking the natural log of both sides, what that does is it sets us up with a situation in which we can use one of our properties. And in this case, and in most cases, it's going to be the fact that we can use the power property. And we can use that because that 2x is in the exponent. And what our power property says is that we can rewrite the natural log of 5 to the 2x as 2x times the natural log of 5. And that is still equal to the natural log of 15. Now remember, the natural log of 5 and the natural log of 15 are still both two quantities. You need to treat them as such. Don't just say, oh, the natural logs can cancel each other out. It doesn't work that way. The natural log of 5 is a quantity, the natural log of 15 is a quantity. Make sure you keep it that way. Well, now if I want to isolate x, I have x times 2 times the natural log of 5. Well, I undo multiplication with division. So x is equal to the natural log of 15 over 2 times the natural log of 5. Often when you're solving these equations, you are going to see your numbers in parentheses, just so it makes it easier to distinguish what you're taking the natural logarithm of. So x equals the natural log of 15 over 2 times the natural log of 5. If you are asked for an exact answer, this is your exact answer. Oftentimes we will work with exact answers, sometimes we will work with decimal approximations. If you're asked for a decimal approximation, all we want to do is substitute this back into our calculator. So we take the natural log of 15, we divide it by 2 times the natural log of 5. You get about 0.8413. If you're curious about whether it works if you took the common log of both sides, you can go ahead and plug that into your calculator, and you are going to see that it works exactly the same. So that's our first example. One exponent, we can deal with that. Well, now what if we have x's in both our exponents? So again, we're given a situation, we have an equation, our exponentials have different bases. So the first thing we want to do is apply our property of equality of logarithms. Again, you can choose to use the common log, you can choose to use the natural log, it does not matter, as long as you use the same thing on both sides of your equation. Again, I'm just going to work with the natural log because I think it's easier and it's one less letter I have to write. So we have the natural log of 3 to the x is equal to the natural log of 5 to the 2x plus 1. Well, in this case, we have exponents in both of our logarithms. So what we want to do is we want to apply the power property to both of them. So the natural log of 3 to the x is the same as saying x times the natural log of 3. And this is the same as saying 2x plus 1 times the natural log of 5. Make sure that 2x plus 1 is in parentheses, okay? That 2x plus 1 is the entire exponent. You have to make sure that that entire 2x plus 1 is multiplied by the natural log of 5. And that's going to be important in this next step. Well, we need to isolate our x's. We have to get them all to the same side. But the only way we can get them to the same side is if we distribute our right-hand side. So because it's the entire quantity of 2x plus 1 times the natural log of 5, what we can do is distribute both of those. So our left-hand side stays the same. We have x times the natural log of 3. Well, when we distribute, we have 2x times the natural log of 5 plus 1 times the natural log of 5. Well, now we need to isolate our x's, so our x's have to be on the same side by themselves, and we move this 2x times the natural log of 5 by subtracting it from the left-hand side of the equation. Well, we have x times the natural log of 3 minus 2x times the natural log of 5 plus, or equal to, sorry, I subtracted that, equal to the natural log of 5. Okay. Well, now I have an x in my natural log of 3 and an x in my 2 times the natural log of 5. I need to get 1x. Well, how do I change a sum or a difference into a product? I factor. So what you're going to do is you're going to go ahead and factor out an x from each of the x times the natural log of 3 and the negative 2x times the natural log of 5. That's going to leave you with x times the natural log of 3 minus 2 times the natural log of 5 is equal to the natural log of 5. And then if we want to solve for x, well, how do we undo multiplication? Division. So it's going to be x is equal to the natural log of 5 divided by the natural log of 3 minus 2 times the natural log of 5. And again, this here is your exact answer. Okay, so we used our power property. Okay, we distributed the 2x plus 1 so that we had individual terms with x. We subtracted the 2x times the natural log of 5 to get all our x's to one side. We factored out the x so that we had one x to solve for, and then we divided to give us an exact answer. And again, you can do this as an approximation. So we're going to do the natural log of 5 divided by the natural log of 3 minus 2 times the natural log of 5. Make sure that denominator, that whole thing is in parentheses. It's about negative 0.7591. Okay, we are going to do another example of one of these. So 12 to the x minus 4 equals 4 to the 2 minus x. Again, our bases are different. It's not easy to write them as one exponential. So we're going to take the natural logarithm of both sides. So we have the natural log of 12 to the x minus 4 equals the natural log of 4 to the 2 minus x. We're going to apply our product property. So we have x minus 4 times the natural log of 12. Oops, sorry, that wrote weird. Times the natural log of 12 is equal to 2 minus x times the natural log of 4. Make sure that 2 minus x and the x minus 4 stay in parentheses because the entire thing is your exponent. Now we want to isolate our x's, so we're going to distribute. We have x times the natural log of 12 minus 4 times the natural log of 12 is equal to 2 times the natural log of 4 minus x times the natural log of 4. Well, now we need to get all our x's to one side. I suggest you add, okay, that x so it stays positive. So our left-hand side is going to be x times the natural log of 12 plus x times the natural log of 4. We are going to have this equal to. We want Okay, our constant to be on the other side, so we're going to add the 4 times the natural log of 12 to the other side. So we have 2 times the natural log of 4 plus 4 times the natural log of 12. Again, how do we get that x from being in a sum to into one term? We factor, we have x times the natural log of 12 plus the natural log of 4 is equal to 2 times the natural log of 4 plus 4 times the natural log of 12. And then what we're going to do is we are going to divide each side by the natural log of 12 plus the natural log of 4. So we're going to get 2 times the natural log of 4 plus 4 times the natural log of 12 divided by the natural log of 12 plus the natural log of 4. So if we want that in exact form, it's going to look like x is equal to 2 times the natural log of 4 plus 4 times the natural log of 12 divided by the natural log of 12 plus the natural log of 4. Again, if you want an exact answer, plug it into your calculator. Make sure both your numerator and denominator end up in parentheses. Otherwise, you're going to get an incorrect answer. So just make sure you do that properly. When you do that, you should get x is about 3.2838 for your approximation. If you have any questions, make sure you reach out or ask during class. Have a good day.